A certain freely falling object released from rest requires 1.50 seconds to travel the last 30 meters. So to travel the last 30 meters, before it hits the ground. So they say find the velocity of the object when it is 30 meters above the ground. Find the total distance the object travels during the free fall. So we'll know, how high the object was when it was released. So this is the ground. The object was released from some point here, where the distance from this point to the ground is really none. I don't know how high it was with respect to the ground. Now, what I know that at a certain point, the object was 30 meters above the ground. Which is just delta y or h. So this delta y is 30 meters. And we know also that the object spent a time of 1.50 seconds to travel these last 30 meters. Now, what are we supposed to calculate first? We want to calculate the velocity of the object when it moves exactly here, 30 meters above the ground. And then I will call this velocity initial velocity. We'll call this velocity initial velocity because it's just the velocity the object had at that point, 30 meters above the ground. My final velocity would be the velocity when it hits the ground, 1 instant before hitting the ground, or I could just take also final velocity, 0 if it's after hitting the ground. So it depends more of how the statement of the problem. So what I'm doing next, I say, well, let me review in my knowledge about equations of kinematics, what equation you can relate, my nouns and unknowns. So I know the delta y, I know the time, I know that it's in free fall, so I know that the acceleration is the acceleration of gravity. So I'm pretty sure that this formula is going to work. So delta y is equal to v sub 0 t, v sub 0 y, of course, but well, just v sub 0 t, plus 1 over 2 gt squared. Right? I know that this formula is going to work because in this formula I have all the different variables that are involved in this problem. So delta y, the position above the ground is 30 meters, the time that it takes to travel to 30 meters, that was 1.50 seconds, and the initial velocity, that is what I want to calculate, and of course, then the acceleration of gravity that is a constant. So I will be solving for v sub 0 here. So we say delta y minus 1 over 2 gt squared is equals v sub 0 t. Of course, we know that this 1 over 2 gt squared is 0.5 gt squared, so we just rewrite that without a fraction, just the 1 over 2 as a decimal number to make it easier, to make the formula look better. I will divide now by the time also to isolate v sub 0, so I can say delta y is equals, delta y minus 0.5 gt squared over the time is equal to v sub 0. I can now substitute, and I get that v sub 0 is equals delta y 30 meters minus 0.5 times g, that is 9.8 meters per second squared, acceleration of gravity, times the square of the time that takes the object to go from 30 meters above the ground to the ground is 1.50 seconds. It's 1.50 seconds squared. And all these divided by 1.50 seconds. So when we perform those calculations, we're going to have, that the velocity of the object when it was 30 meters above the ground was 12.65 meters per second. Well, this is this speed, so this is just the magnitude. If I want to show this vector as velocity, we say that this initial velocity was 12.65 meters per second south, roll downward. Right? Or just downward. It says south, maybe it's not accurate, because I really have an object, that is falling. So south makes make more sense when the object is just moving, horizontally. So uh, on the surface of the earth, right? So it's going to make more sense to talk about south or north, east, west. So let's say that just downward. It's going to be more accurate. The second question here is just find the total distance the object traveled during the fall. So what about the second question? In this case, we want to know, right, what is the total distance the object just travels, uh, during the fall. So I know that from this point here, where the velocity was 12.65 meters per second, the object was 30 meters above the ground. So what could be important to me now is just to find this distance that is unknown, that I will call delta y prime, right? Because if I find delta y prime, I can say that the total distance traveled during fall would be delta y, this delta y over here, plus delta y prime. So this distance over here. So what I need to do is just to calculate that delta y prime. Now, what I know, and then now we're going to change a few terms. We're going to change the notations a little bit, because now what was initial velocity here, when the object was 30 meters above the ground, if I want to find delta y prime, that would be final velocity, right? Because we're going to have the object now at, this height, that is the total distance above the ground. And then is released from rest. So here we have initial velocity 0. And then now here we have the object when it's at 30 meters above the ground. Above the ground. And then we know that the velocity had that in the previous step of the problem, I just considered that initial velocity now is going to be in this interval that go from point when it released to 30 meters above the ground. This will be now the final velocity. At that point, it is 12.65 meters per second. And then what I want to do is to find this distance that I have called delta y prime. So let's see which are the norms and the nonce. We have initial velocity, what relief from rest, so 0. We have to find a velocity 12.65. Know that this velocity when it's at 30 meters above the ground. We know the acceleration of the gravity, which is falling in free fall. What we don't know is delta y prime. So I will just go and review in my archive of equations of kinematics, all that, group of equations that I have in my mind. And I say, oh, I now remember one equation that relates these variables. The equation that say that the square of the final velocity is equal to the square of the initial velocity equals to g, in this case, delta y prime. So if I know the velocity between these 2 points, and if release it and 30 meters above the ground, right, I can just use this formula to calculate how far, how above 30 meters was the body, going to go with this. So now I can solve for delta y prime, of course, this initial velocity equal to 0. So we say that bf squared is 2g delta y prime, and then we divide by 2g, and bf squared over 2g is delta y prime. So we can say that, of course, delta y prime is just 12.65 meters per second squared over times 9.8 meters per second squared. And these would be, just a perform the operation, it would be 8.60 meters. So my delta y prime is 8.60 meters. So now I know that if this value over here is 8.60 meters, that is the distance from the point where the object was released to when it was 30 meters above the ground. But now I know, that there is also this distance, right? It's just the 30 meters above the ground. I know now that the total distance is my delta y of 30 meters plus my delta y prime of 8.60 meters. So this would be 38.60 meters, which is approximately 38.2 meters. 38.2 meters. I am writing my number with three significant figures, right? Just to be clear with that, also let's say that this here should be 12.7 meters per second. We have three significant figures also. Right? So I was able to calculate using the equations of the kinematics, right? What was just the velocity of the object, what was 30 meters above the ground, and also what was the total distance that the object traveled to know when from the point where it was released to when it hit the ground. So this is a very interesting, one exercise of before.